I'm going to welcome you to our event today here at the stage of the LogiMAT. Someone just complained in Hall 6, and the LogiMAT Managing Director, Michael Ruchti, was sent over there because there was a complaint, and the complaint was there are too many people in the aisles. And I thought, what kind of complaint is that? I thought that was the purpose of this event. I mean, but that's not our problem. So our topic today is Quo Vadis mobile robotics. What's next for mobile robotics? And we're going to focus on a few topics that are dear to our hearts. Why are we doing this? My name is Günther Ulrich, and I am in the VDI. I am head of the Technical Committee for Automated Guided Vehicles. That's a technical committee that we founded a few years ago, and we can say that, well, it's been quite a while because it was founded in 1986-87, at the end of the year 1986, and that was a long time ago. And we started dealing with AGVs. And in this technical committee, we are, of course, dealing with things like writing guidelines, organizing events, writing VDI regulations and keeping them up to date and so on. And so my entire professional basis basically was emanating from this VDI technical committee. I'm also heading the AGV forum in Hall 6, where we are doing planning, we are consulting. It's an association, it's a society of interest of the industry, and that's what I'm doing there. And in the VDI technical committee, we have set up a working group a while ago dealing with the future of AGVs, with questions of the future. And that's this work group entitled Quo Vadis. And the former head of this working group is also sitting over there, wearing red and white. Harald Bergermann, a dear friend of mine. He's sitting over there. He was head of the working group, and he said at some point in time, that's enough. I don't know what he used as arguments, but it doesn't matter. And then we set up, or we found a new head of the working group who's now getting started with his work, and that's Marco Bernstein. He's to my right from company Prolog. And Marco is going to be talking about what he has in store for us and the topics that we are going to be addressing in this working group. And if you think that certain topics are too theoretical, then in the second part of our event here, we're going to become more specific, not only highlighting specific issues, but we're going to also present solutions where you might not imagine how far we would go with our work. These are that we actually find good solutions for certain problems, and that's about the topic of an outdoor use. So if I use an AGV and use it to move around outside, outdoors, on the plant premises, for example, and then there are a few requirements I need to comply with. We're going to be talking about those. And I need certain things that help me having a very secure and safe operation of these AGVs outdoors. And that's the second part of this event, and Thomas Albrecht is going to be heading that. He is also part of the technical committee of the VDI for many, many years, and he's from the Fraunhofer IML in Dortmund, and he's heading the area of AGVs there. That's our plan for the session. I hope I have described it enough. And I hope you're going to stay with us because it's going to become really specific in the second part. And I'm now going to hand over to Marco. And Marco is now going to be talking about his working group, the topics of which we believe they're going to be important for the future of AGVs and mobile robotics. Thanks, Günther, and hello, everybody. My name is Marco Bernstein. I'm from Prolog Automation, I'm a partner manager. We are located in Freiburg, and for 10 years I've been active in the VDI Technical Committee, and I was pleased to take over the lead from Harald this working group. And the three topics that we are tackling with Quo Vadis are the necessity that we have to change the education and training of engineers and the lack of skilled workers, then AGVs in use and outdoor use, but also the outdoor use. And we're going to be talking about that in a minute. Thomas is going to elaborate on that. Just to get an overview of what we're actually doing in this working group of the VDI, I will try to highlight our tasks. Some of you might know this working group. First of all, we work out guidelines and revise guidelines. Probably everyone listening in today might have heard those, read about it, or implemented it, or have referred to that. That's what we do. And how do we do that? Well, first of all, we have it's actually a future-oriented project. It will always be continued. And in our working group, we have a certain strategic circle under the head of Günther. We have organization teams taking care of the technology, the planning, and also safety as a separate topic. And apart from that, we have several working groups, but Quo Vadis is not one of them. Quo Vadis works on those topics that come up later. So either that will be transferred to these planning security working groups later, and either this will be turned into guidelines or into certain directives. So topics that concern us today and will concern us tomorrow. In Quo Vadis, we first draw up guidelines, and you're probably familiar with one of the other guidelines, AGV safety, for example, or the most topical ones, according to players and phases and rollers. This was also something I was involved in. I can just recommend it under the VDI website or at the forum of AGVs, Günther in Hall 6, as you just mentioned. So it's a must. So apart from outdoor applications, we also want to address the lack of skilled workers. It's something everyone is concerned about at the moment. And we also look at the small industry of AGVs, mobile robotics, and how do we handle that. Lots of companies are being founded. The market of providers is getting bigger and bigger. More and more projects are coming up. And everyone is looking for skilled workers in order to implement their projects. So we need to question this according to our motto, Quo Vadis. What's next? What is going to become of this? And so we also question the traditional educational classes or courses. Is it still the traditional automatic technician or the mechatronic? And in mechanical engineering, is it still sufficient to qualify or to study electrical engineering and mechanical engineering, or should we become more specific here? And I believe that we have several really fashionable studies but why is mobile robotics not covered? And that's something that we are dealing with basically in our working group. And this brings me to Thomas. One slide back, please. Yes, is it my turn? I want to add something regarding the guidelines that my colleague just mentioned. They really are of enormous help. We actually transpose them into official VDI regulations. It just takes a bit of time. That's why we start with these guidelines, because the process in the VDI takes quite some time. And we have two highly interesting safety guidelines. One is for planners and the other one is for operators. So safety for AGVs in inner plant use. Very, very important. Should really take a look at those. And I would also like to point out one guideline, which I believe is the most fascinating one of all. It's the guideline for autonomy. So for autonomous behavior, autonomous functions in mobile systems, so mobile robots. Because we know this buzzword, we all know the buzzword autonomous. Everything needs to be autonomous. And in very few areas, people actually talk about what it means, whether it's good or bad, whether you need it or not, and what you need it for. And there's a specific guideline with Excel spreadsheet in German and English. You can find on the website of the AGV forum. It's very important because gives you a fundamental understanding of the situation. So please take a look at that. It really helps you when you need to make a decision whether you need it or not and what the role is supposed to be today. But Thomas is back, so we can move over to the outdoors. The outdoors, that's also something, well, you know that this is being neglected oftentimes. We ask ourselves, why are there so little projects outdoors? And when I'm talking about outdoors, and I don't mean the road traffic, but I mean on the plant premises. So in plant use, there's a gate to the plant premise, and then we have the halls behind the shops, and we have mobile robots and AGVs, and we love to drive around the shops. But outside the shops, there are comparatively few projects on this, and there are reasons for this, and we want to talk about the reasons, and we'll support you with that, what you might look into, what might help you, so that we can achieve a breakthrough in this area, because that's the goal here. Thomas?
Can you hear me? Is it loud enough? I'm Thomas Albrecht from the Fraunhofer Institute for Material Flow and Logistics, IML in Dortmund. I've been dealing with this topic, AGV, for quite some time, actually all of my professional life, and I try to figure out how long. Actually, I think it's more than 20 years, actually, working in the field of AGVs. Okay, outdoor use. This is what it says on the agenda, and I would like to take a step back. Similar problems, not fully identical. Similar problems is something that we can also find in the indoor area. So whenever we have different surfaces on the floor, and here we have similar problems like outside, and this is what I would like to focus on. There are various VDI guidelines, we heard about that, and there is always a guideline basically on a floor suitable for AGVs. So what sort of requirements has a floor to fulfill if you want to use AGVs in your factory? Well, there are recommendations, guidelines, for example, for the construction area. And in the end, the idea is that the floor should be as flat as possible and not wavy. There shouldn't be any holes, no holes, and this is rather suitable for these automatic vehicles. So this is something that you can achieve. I brought you two pictures of bad floors. So inside you can do quite a few things, but outside to have an even surface is much more difficult and is usually quite expensive. So you have to try to live with this bad floor. So you have to try to find a compromise of what is still acceptable and what isn't. To put it in concrete terms, well, there is a problem if there is bad floor, if it's wavy, uneven holes, if it has edges, if there are doors, and so on. And these problems become problematic when the vehicles have more than just 3 wheels. You are familiar with that, for example, like when you have a table or a chair with 4 feet, and then it starts to be uneven. Which means that if you have a vehicle with 3 wheels, that's not a problem. there are other problems that a three-wheeled vehicle could have. So the problem at hand is that you would like to use a four-wheeled vehicle, but four vehicles are difficult to, put on the floor. And if one of the driven wheels loses contact with the floor, it's really a problem. The vehicle might either change direction or it might come completely to a standstill. So how can we solve this problem? So from the perspective of the user, and they probably don't want to hear that, first of all, you have to make sure that you have a good surface on the floor. This is what the users don't want to have because it's quite expensive. And this could lead to a situation where a planned AGV project is not implemented because the AGV supplier says the floor isn't good enough, we can't have our vehicles driving on that, and then the refurbishment of the floor is too expensive and the whole project is cancelled. So saying no to the use of AGVs is actually not an option. So what else could you do? Well, you could use free vehicles on the free wheels on the vehicle. Okay, there is also a disadvantage because if there are sharp bends, the vehicle tends to fall over. So in particular, if the load is distributed unevenly, it could tilt. So that's not good. So if you want to avoid that, you need to have additional wheels, and then you have more than three legs or wheels in this case, and that's not good either. So you should have vehicles with four wheels. Then the question is, where do we have the drives? Left, right, middle, whatever. Let's take the example. I have a flyer. No, I don't. Well, a vehicle which is sort of rectangular. You have the driven vehicles in the middle, and then you have supporting wheels in the front and the back. And this is, of course, helpful if the vehicle wants to change its direction. It can turn around the center. It can rotate. So with this setup, which is theoretically quite cheap, I have four points of contact, which is difficult with bad floor. What could be our solution? Well, you could say, I'm going to take one of these four wheels, a supporting wheel in the front and the back, and I add a spring. But this brings us to the next question. How do I dimension the spring? If it is too strong, it's going to pull the vehicle upward. If it's not strong enough, it doesn't work at all. And this really has to do with the load on the vehicle. So maybe you have an empty vehicle, 300 kg, and a fully loaded one weighs 1,300. So you need to have a spring and dimension it for both cases, and this is basically impossible. So with a lot of effort, you could say maybe I need 3 or 4 springs. I need to have a parallel setup and activate them separately, so that would be over-engineered. You don't do that. You do that? Okay. You can do it. Never mind. It's quite a lot of work. Well, there is another possibility. Namely, you take those driven wheels from the center and make sure that they are on the floor. And then you have the supporting wheels and make sure that they're a bit too high so they are not in contact with the floor, and depending on the state of load. So for example, for acceleration or deceleration, we have this effect that the vehicle moves a bit to the back or tilts a bit to the back, where we have the supporting wheel, so it's driving on the middle wheels and on the supporting wheel. And when it brakes, it moves and tilts a bit to the front. It doesn't look nice, but this is something which would actually work. It's of course a bit stressful for the vehicle. So if you have, for example, products made of glass, you probably wouldn't do it this way, because there would be too much forces being applied to the load. So you can do that, but it's not really elegant. And we, as the Fraunhofer Institute, we offer applied research, and we're quite close to practical life, in particular in Dortmund, very close to the industry, which means that we also produce AGVs. So when I'm talking about that, it's not just pure theory, but we really encounter these problems in our projects. So we had a big a project for an automotive manufacturer. We built a vehicle which was set up the way I described it. We have two drives in the middle. We have supporting wheels in front and the back with no real connection to contact to the floor. And as I said, we have this tilting behavior. Nobody said anything. We concluded the commissioning. Then we walked around with the CEO. And then he said, it's not really so nice that we have this tilting movement. I don't want that. And then we had to, go back and think about that and ask ourselves, what can we do in order to come up with a functional solution in order to avoid this tilting behavior on the four-wheel drive. And this is what you can see here on the video, or in Hall 1, K61. Here you can also see the vehicle. So this is the parkour that you can see on the right-hand side. So we have the floor with different small obstacles. And the vehicle has this setup with these four wheels. All of them are always in contact with the floor. There are no springs, actuators, or some other sort of high-tech. It's pure mechanics. It's rather cheap to produce and install. It's quite functional and robust. And this type of solution on bad floors in the interior, on the inside, is something that you might also use on the outside, where the probability is higher that the floor is uneven. So not really suitable for an AGV. Okay, and this brings us now to an example from outdoors. Okay, let's stick to the AGV suitable floor. You mentioned a couple of things. A floor suitable for AGVs also means that you need to have a certain level of friction in the indoor area. So in the hall, that means that the friction shouldn't be too low, but it shouldn't be too high either, because if friction is too high, you have a lot of wear and tear on the wheels. So these wheels are going to be worn down quite quickly. So inside, with the coefficient of friction, well, you try to stick to a certain level. And of course, you can discuss that, you can do that. Outside, of course, the situation is completely different, and this brings us to the topic. So outside, I have rather different conditions on the floor, and we have to keep in mind what we want to achieve. So we use the AGVs in a company, and they are equipped with sensors also to protect people. They are using laser scanners for people protection, and there are rules, safety relevant rules, and one of them is 36911, a DIN ISO standard, and here it says that when you use such a vehicle, you're not allowed to hit a person. And I just give you an example. So there's a person standing somewhere, or maybe someone is unconscious lying on the floor, so the vehicle must not hit the person. Of course, it is quite clear that if you set up this requirement, you have to make sure that at any given point in time, the braking power can be achieved. So I have to have a certain coefficient of friction for braking. So I have to have a coefficient of friction between the floor and the wheel. So indoors, you can easily do that, and you can do a risk assessment And you can say, okay, in this case it is okay, we have the right coefficient of friction. It's bad enough that you can discuss that even further and question that, but on the inside we are quite safe. But if I go outside, you will understand that with this mu value, it's not so easy, because we've already heard that there are floors which are quite different. We have different seasons. We have snow, we have ice, we have water, rain. There might be oil stains or other contaminations because of leaves, for example. And there is also the problem. I mean, you might think in summer everything is great, but the asphalt could be really hot and then it becomes slippery. So I would say that outside we have conditions that I don't really know in detail. So I can't really make a good assumption, different to the inside, of course. This is a big problem, because what I want to do, and I'm going to come back to that in a minute, we want to move faster than on the inside, because in most applications I would like to move rather quickly outside because the distances are bigger. So I want to drive at a certain speed, and on the other hand, half mv square has to do with my capability to brake. What I need in any case is, in order to make a statement regarding the braking capabilities, is the coefficient of friction. And now it's getting difficult. How can I get to this coefficient of friction? Actually, I would need it at any given point in time, at each and every minute, second actually. So I have to differentiate between left and right. So if you have 4 wheels, you have one on the left and one on the right, and the mu values might be different from left to right. And if I want to be safe, and I'm sure you will, everybody wants that, because I want to comply with 3191.1, so I have to have this mu value. And if I don't have it, I could say, okay, I want to be on the safe side, so we're going to drive slowly. I could set a safety speed and drive very slowly, but this is not what this is all about, and the operator will probably say, what's this supposed to be? I mean, it should drive faster. So the knowledge of the coefficient of friction is a very central issue. And I believe that this is also a reason why there are only so few applications. And now the question is, how do we handle that? There is a new paper from the the liability insurance, I think was published 10 days ago. This was about outdoor use, and here it says that the condition on the road has to be known by the vehicle, and the vehicle has to be given that information. I'm not really sure. I mean, you can ask for that, you can say that, but I'm not really sure how to do that. Somebody has to tell the vehicle what the coefficient of friction is at the moment. And the idea behind that is, I believe, this is what they thought, that somebody looks out of the window and says, it's snowing, it's raining, there's sunshine outside. So you tell the vehicle when it's snowing, when it's slippery. Then you tell the vehicle, okay, it's slippery outside, be careful, don't drive too fast, or you're not allowed to drive at all. This could also be a possibility, but of course this is only half the truth, because with that is only a certain percentage of all these possibilities that can be covered. And this is why I believe it is absolutely mandatory. If you want to use it outside, you need to know the coefficient of friction left and right. And now we can think about that, and we did that in the AGV forum. We thought about that, and we have developed a process which can be installed in the vehicle, and which takes a look at the left and the right lane and monitors both and knows what the coefficient of friction is on the left and on the right. And this process, of course, has been applied for a patent. I can't give you all the details, but I can tell you that there are possible solutions. But everyone who wants to have automatically driving vehicles outside has to be able to use something like this in their vehicles. I don't see any other possibility to have an acceptable operation with acceptable vehicle speed without such a device on the vehicle. So I would say this is the decisive point, and what I can tell you is that it exists. You can add that to a vehicle so that you know the coefficient of friction at any given point in time, left and right. And if something like that exists, because it is a technical solution, well, you have to install it first of all before you start to solve that with other measures. So the technical solution is in the forefront, and I think this is quite exciting, and we're going to talk about that in more detail. This whole task of using it outside of this working group, and we're going to wait and see what lessons we can draw from that. And this brings me back to one point, and this is something that we also should look into. We have said that we have this surface which is not even, which is not clean. This is one point. Secondly, we know that we need the coefficient of friction. And the last point is that we want to drive fast. We want to drive faster outside than it is possible inside under normal circumstance, 1.5 meters per second. Most AGVs usually drive about 1.5 meters per second. So maximum, I think, is 2 meters per second. And outside we want to drive faster. And what that means for the mechanical part alone, this is also something that has been looked into by the IML, the Fraunhofer IML. Thomas? I think Thomas is going to tell you more about it.
Yes, that's actually more the R&D part of our work. It's not a customer assignment, but it was our own initiative, and we dealt with this question. How can we drive quickly outside? And ideally in all directions, so no limitations, as a three-wheeled vehicle has, because it only has a tangential curve. As you know it from your car or your truck, it's rather immobile and needs a lot of space to maneuver. And so on our wish list, it said that the vehicle should be movable in all directions, in all spatial directions, so that we can have it move on uneven ground and quickly. And what you see here in the video is the result of approximately 1.5 years of development work and construction work as well. So the vehicle was built in our own workshop. The software was programmed, the sensor data was assessed, the drivetrain, everything was developed in-house. And it is now something like a test or prototype. It's a big toy for adults, you could also call it. You can collect lots of measurement values, and what you just saw, you can write it outside as much as inside. So you have a differential GPS where you do the navigation, and inside, indoors, you have 3D scanners and LiDAR sensors to do an environmental navigation. You probably just saw that the vehicle can also have different heights. It has an active suspension unit, spring suspension unit, so it's an air suspension vehicle, so that it has a lot of ground clearance in order to go over uneven areas. And the second use of this air spring or air suspended chassis is that you can use it at the same time in order to pick up pallets or load. So in this case, the frame was lowered, then you have a finger under the pallet and it pumps up so that it has more ground clearance and can actually lift the pallet off the ground and move around at high speeds. And we just mentioned that already. In outdoors, if you have long distances to cover, you can drive quickly so it doesn't take as long. And we have mecanum wheels on them. Now we've already done tests with side wheels, and we have very strong DC-DC motors that we used. It's basically an all-wheel drive that is being installed here. and we have speeds of up to 10 meters per second. Those of you not familiar with this unit, it's 36 km/h, and for an automatic guided vehicles is a lot, because indoors you actually have pedestrian speed, so it's 5 to 6 km/h, and so 36 outdoors is quite a lot. Yes, if I understood you correctly, it is the design wasn't that easy to realize. And what I saw with awe was that in the audience among you, we have the developers, the design engineers of this vehicle. And there are two gentlemen who are basically from Thomas Albrecht's company, Max Gössner, and my son. And we're just going to ask them, and I have a microphone here, we're going to ask them how that was, the development. So these are the two gentlemen who worked on this chassis in the IML. And Thomas already told us that the requirements and the technical highlights were 10 meters per second, mecanum wheel. And we would like to know what was the special feature or the special thing about this project, special challenges that you encountered, what you really enjoyed doing, and on the other hand, what are the future perspectives, use cases for this quick vehicle? That's also an important topic. Well, the special fact about this project was the big freedom that we have with this project. It wasn't a customer assignment, it was a publicly funded project and as part of the silicon economy. And what we saw in the vehicle, in the video, the vehicle is not a serious product, it's not an industrial product, it's a showcase, it's a test vehicle, it's basically a prototype for research and development. We can learn from it, we can create new functionalities and design new functions, and that was now handed over. It will be handed over to real serious production later. What use cases do you see, Max? Well, clearly the transport between different shops, as it was just mentioned, just making sure how we can connect the production shop with the warehouse shop, and how can we manage the transport in between as quickly as possible and as safely as possible. What's the load capacity? Currently, the prototype status has, well, including the frame and the chassis, we reach certain limits, but now it's roughly 350 kilograms payload that we can put on top. But that's the first version of this vehicle. We can really achieve more than that. What's the special thing about these wheels? The mecanum wheels, yes. We are really flexible. We can do fine positionings before in front of the load carriers. We are specialized here. We have very precise, fine positioning that we can implement and are much more flexible than with conventional chassis. Anything else you would like to add to this project? Well, it's a thrilling project, and of course, this outdoor use is the path for the future of this AGV industry, and we just wanted to show you the few examples with what technologies and what opportunities you can actually join this journey towards outdoor use. And if you, as a design engineer, would like to take the same path, and please address us, get in touch with us. You have Thomas Albrecht's contact data here on the flyer. We would love to support you on this journey into an outdoor future. Thank you, Niklas. Thank you, Max. Okay, so we have come full circle. We talked about quick driving or high-speed driving. We talked about friction values outdoors. We talked about positioning, about the floor conditions that can be so different, the ground conditions. Now we just have to include that in our working group, that we highlight these aspects and combine them and try to find more reasons why we don't see as many vehicles outdoors because that's really stunning. I mean, on the one hand, we talk about what's happening on the road. We want to have autonomous driving on roads and road traffic. And on the other hand, we have the mobile robotics industry, AMRs, AGVs, and shops. That's okay, but we do on the plant's premises, in between shops. That's just a really sad story. And of course, we're going to be highlighting these aspects. I told you that the VDI Technical Committee is so old. I mean, we always looked into the shop floor use. We looked at inner plant transport on the same shop floor. Now, step by step, we get new use cases. The first stage is riding the vehicle outside. The other one is on the plant premises, but in publicly accessible areas. And that's another point, something we also have to be dealing with. And then, of course, then there's the autonomous driving on the road in road traffic. That's a whole different story. So these are basically the challenges we're facing, and we need to reflect them with our safety ideas. I mean, safety is first in Europe, at least in the EU. It is absolutely first. What happens elsewhere is a different thing. But we have to deal with these aspects, and we'll be doing that. What does it mean, publicly accessible areas? I mean, you also see that outdoors, almost always, you notice that because the plant premises are not necessarily controlled in a way that you can make sure that it only has instructed employees on site who know that these AGVs might be hazardous, how they function. On plant premises, it's possible that you have someone from the management level, administration, going over to the cafeteria, or you might have visitors on site. It's also possible that from a truck trailer, not only the driver gets out and looks for a restroom, but also his entire family that he's carrying around with him. These things happen, and you always have people running around on plant premises you don't need there and really cause problems, safety issues. So publicly accessible areas cause problems, and that also in the hospital area. In hospital logistics, we have exactly these two steps. On the one hand, you have transport in the basement area where you have instructed personnel, and then on the different stations, you have patients running around and visitors and the like. So this field of tasks is a huge one. And I'm basically through with my session here. Anything you would like to add just to wind up the session? Anything, any contribution you would like to make? In the VDI Technical Committee, I mean, we're still looking for helpers. So if you want to get involved in the work of the VDI Technical Committee, get in touch with us. I think it's important that we all are committed, that we pave the way for a safe industry, for safe use cases, and even more applications in the various areas where we use mobile robots and AGVs and AMRs. So, and I would like to point out that there is an event that is just as thrilling as this one. This will also be involving me. Tomorrow, we will be talking about this parallelism of intralogistics and autonomous driving in road traffic. So we can take a look at intralogistics, mobile robotics, and road traffic, and what can we learn from observing both intralogistics and transfer it to autonomous driving on the road. It's going to be a fascinating story. We'll have a very interesting panel as well. I think it's at 11 a.m. tomorrow, same location. Just a quick reminder. It will be a fascinating discussion with different opinions, and I can promise you that. We could maybe give you a quick literature tip. Many thrilling topics in the AGV field. We just talked about a very small window, basically. And there's a nice book on this, the the FTS Bible, basically. It is, you can find it. Was just published, and it's an online library presence. Many examples from practice, but also topics such as what problems you encountered during outdoor use, how you can resolve that, or what you need to take into account in hospitals logistics. So everyone intensively dealing with this topic, our potential readers, and everyone planning an AGV use in the near future. So want to introduce such a system in the near future. And that would be a good introduction to the topic, just to read about this complex subject of AGVs. And afterwards, you can discuss this at eyes level with planners and suppliers. The English version was published roughly 2 months ago, and a new fourth edition of this FTS AGV Bible in English will be available next week from Amazon. So I can promise you that it's a good read. I already read it. I didn't only read it, but we wrote it actually, Thomas and myself. So we can really recommend it. Quite an interesting book. So we've reached the end of our session, and we've reached the time limit as well. Any questions, urgent questions we would need to respond to. But as I said, we are here available at the trade fair. You can get in touch with us. All three of us are at our respective booths. And if you are in the mood to contribute working with the VDI Technical Committee on Transport Systems, then just get in touch with Thomas, Marco, or myself. We're all willing to get new people on board. Thanks very much, and enjoy the rest of the trade fair. Thanks you for being here. See ya.